In this problem, a farmer has been trying to create a nice rectangular area for her garden. She has 360 feet of fencing, and so first we want to write an equation needed for the perimeter of the garden, where L is the length and W is the width. Since the farmer is going to fence all four sides, and two of them have length L and two of them have length W. So altogether, because the perimeter, you just add up all of the sides. For a rectangle, it's 2 times the length plus 2 times the width is equal to 360, because that's how much fencing she has. Next, we want to write an equation of the length of the garden in terms of the width. In other words, solve for L. So first, subtract 2W from each side, and then divide both sides by 2. And simplifying, we get L of W equals 180 minus W. Well, now we want to write an area formula for the garden in terms of the width, written in standard form. So for a rectangle, area equals length times width. Since we just found an expression for the length in terms of the rectangle's width, we will substitute that expression for L and then distribute. And writing this expression in descending order, we get A of W equals negative W squared plus 180W. And the point 50, 6500 is on the graph of this function. What is the meaning of this point? Recalling our area function is written in terms of the width, we can label these coordinates as shown. So when the width of the rectangle is 50 feet, its area is 6,500 square feet. And the vertex of the function is found at 90, 8100. What does this mean in terms of the problem? So graphing our area function, we see that the vertex is at a maximum. With 360 feet of fencing, the maximum area would be 8,100 square feet when its width is 90 feet. And lastly, what is the width and length needed to get the maximum area of the garden? So we already know the width, which is 90 feet. And since we know this relationship between the length and the width, and that L equals 180 minus W, substitute 90 for W and evaluate. And we find that the length is also 90 feet.